Right, good evening everyone. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre South. Broadcasting on prime frequency 3541 kHz in the 80 metre amateur radio band, lower sideband, and on the Melbourne digital television repeater, VK3 RTV, channel 1, in full HD, and also on my YouTube channel, VK3CSJ. Just type in VK3CSJ in the Google search engine and all will be revealed. Okay, we also have an email address if stations wish to send me signal reports. My glasses keep sliding down my nose. It's really beginning to pee me off. We have an email address, vk3csj@gmail.com. So signal reports are welcome. And we also have a Discord chat window. So if you have Discord installed, and look for the astronomy chat room, I guess is another way of putting it. I'm still not too sure how that works, but anyway, I'm not sure if you're listening there, Richard, but good evening, Richard. I'm on the 23 centimetre frequency. This is VK3 EKH. Okay, I apologise for not being here last week. I rolled up here at about 9 o'clock to get ready for the 10 o'clock session, and I discovered that the Radio Shack was disconnected more ways than one, and I figured it was going to take me at least an hour to get it all back together. Righto. So I looked at it all in dismay, and I thought, not that I really wanted to do it, but I did. I decided to take the night off, and figured I'll try and get the station back together again before tonight. Well, it was only a couple of hours ago that I got up here to make a stab at it all, and you know, two of my sub mixers that I use for both the icon boxes that I use for 80 and 160, there was a small accident that I had last week with those two boxes, and would you believe it that the power switch on both boxes got damaged? I couldn't use both tonight. How's that happened? I just don't know, but in the small accident that I had, I ended up scratching the front of the screen too, my curved screen. I'm not very impressed with that. Anyway, so I'm using a slightly simple arrangement tonight. So hopefully the audio on 80 meters should sound okay. And let me know if it's too loud or not enough or whatever. I seem to be modulating okay. And making sure that I don't overdrive YouTube feed. But I'm here tonight, and we've managed to get a few little articles together. Unfortunately, there's no solar report from Tamitha. It'll probably come out just after I finish tonight. But she did release a hour and a half solar report during the week for her patrons, and I got halfway through that. But she's really interesting, young lass, when she's talking about our sun. But I do prefer the 10-minute reports that she does rather than the hour and a half. So anyway, there's nothing there to show tonight, unfortunately. Anyway, there it is. So a pleasant good evening. We've got a few folks there on the chat window as it is. G'day Brendan O'Brien of astrophys.com fame, he's there. G'day Remus, and Bill, VK3KHT is there. G'day Bill. Martin, VK7JAH, Cassiopeia, more nebs. Astrophys, Daz, our resident shortwave listener and project builder up there in Brisbane. And Martin, yep, okay. I think that's all I can see there. And Andrew VK3KI is first off the ranks with an email for me. G'day, Ian, Andrew. No worries. Glad to be here. It looks like a good footy match at the moment. So for those that are keen on mad football, the current footy match on Channel 7 looks pretty tight. It didn't look like that about half an hour ago or so, but these two teams have come neck and neck within 4 points, I heard. So it's pretty full on right now. Anyway, enough of that. Looking forward to next week being a long weekend. I think it's next Friday is the public holiday, so we'll be here. So next Friday and Monday is an RDO for me, so it's a nice 4-day weekend. I just hope the weather's good. The deck, as an update on my deck, timber deck for the Astrodome that's coming along. Unfortunately I don't have any pictures on this computer right now. It's all on the laptop downstairs. So what I'll do is I'll transfer some images of the going ons. It's been a bit of a mess. The whole car park out the front here, the garden, let's say, has been ripped up by a backhoe. They've dug a 46-metre trench and about 600 deep, and there's power down it now, and a couple of data cables which need hooked up here, and so they're all in place. So power is now down on the deck. The deck is a little bit bigger than 3.6 by 3.6. In fact, I think it's 3.6 one way and 3.7 the other way. And the concrete plug, as they call it, or pillar, has been poured and is setting. And there's just a little bit more work on the timber side of the deck. There's marabou timber being placed on it. So that's down the far corner. And once that's all complete and finished and done, and give or take a week or two for the concrete to set and dry, I'll then put the word out for this 3-metre scope dome to be delivered. Good, very pleasant good evening to any of the sidereal trading people who might be listening. And then we'll have this dome being assembled in the back corner, and that'll take a couple of days, I believe. If you're curious about what it looks like, just go to on YouTube. Just type in 3-metre scope dome, and scope dome as in one word, and you'll see a few videos on it actually. But the sidereal trading one, there's a couple of good videos that show you the dome being assembled. And I was thinking of doing it myself, but I thought that's a bit ambitious. So it really needs to be no less than a 2-man job, but preferably I think a 3-man job for those domes. Anyway, we'll get it up, and then I've got 3 telescopes to experiment with. So anyway, so hopefully by the end of the year I should have some good feeling for what can be done. And the intention is to do astrophotography, although being here in the middle of suburbia, city lights is a bit tricky, but there are some good nights, and there are various techniques to getting through the haze. There's some very interesting filters that can be used that knock through the haze, and so I'll be experimenting with them. But there's a whole lot of things I look forward to doing over time. So as I develop these pictures and images and whatever, I'll show them here, and it'd be really quite interesting to finally get into the optical side of astronomy. So there it is. You're tuned to VK3EKH, the official station of the Astronomical Society of Victoria. The Astronomical Society of Victoria, in fact, was founded in 1922 and comprises over 1,600 members scattered about the country. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy and to disseminate the knowledge of the science and to provide greater facilities, which it's doing, for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, and they kick off at 8 p.m. in the Mullior Hall, Burwood Avenue, and parking is available Burwood Avenue, Dallas Brooks Drive, surrounding streets. Admission is free. Visitors are most welcome. The meetings do get put onto Zoom, YouTube. There is ASV have their own dedicated YouTube channel, so you can check it out there. Privileges of membership include the right to borrow books, periodicals and publications from the Society's extensive library located at Melbourne Observatory, receipt of ASV magazine Crux, containing articles, news, observing notes and the like, and the free provision of the Astronomical yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a photoheliograph are also housed at the observatory and are accessible to members as well. The Society also has a number of 200mm reflectors available for a loan scheme that ASV runs. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, with the very biggest ones with appropriate training, and they range from 300mm to 1000mm in aperture. Also located on the site is a fully steerable 8.5 metre radio steerable telescope, which members can access with involvement in radio astronomy section. Members are encouraged to make and use telescopes provided, Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. There's actually 21 sections that make up the various activity groups, but in general they range from deep sky observing, astrophotography, lunar and planetary observing, auroral meteor comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research in astronomy in general. That's just a blend. Contact details of various section directors are provided in the yearbook, but if you don't have the yearbook, you have to be a member to have the yearbook. You can easily go to the ASV website at www.asv.org.au. That's www.asv.org. Some like to actually say the letters. .au. So there it is. Every other week there is a email edition of Crux that gets released. It's called the Crux Extra, and it's just a small email publication that gets sent out to members to let them know what's going on and all the like. Please note that the ASV will conform to all government health directives. ASV events may be required to be cancelled, postponed or moved. And of course the weather has a lot to do with that too. If you wish to get more information about the ASV, you can write a letter to the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. But otherwise, the internet is the best place to go. To the ASV website where it's all happening. And that's it. You've got it. Cassiopeia has brought up the link on the dome on our chat window, and that's the very one, Mr. Cassiopeia. So yeah, it just reminds me. It's traditional astronomical dome, and that's what I like about it. It's white, but it rotates from the bottom. Most domes sit on a structure and rotate, and that's fine. I would have loved one of those too. But this particular dome is unique in the sense that it actually rotates at the base. It's big enough to house 3 full-sized adults, and but only one telescope at a time. So I'll start off with my Celestron 800 CPC first. I've got to get a special plate made by that. I'll ask the guys out at Sidereal Trading to make an adapter plate. They're pretty good at doing things like that, and so I don't have to worry about the tripod. The whole deck is isolated from the concrete pillar come aluminium section that holds the telescope. What do they call that? There's a plug, there's a concrete pillar, and then a pier. I did say that, didn't I? The pier. All these words, terminology, I tell you. All right, but that's it. You have to be looking on the chat window to see that. Alrighty then. I think we're all happening here still. Yep. YouTube is still hanging in there. What I did end up running, by the way, last week, I figured if I wasn't going to come up on air live like I am right now, I actually ran an interview that the ASV president, Mark Ascario, did with Lisa Harvey-Smith, Professor Lisa Harvey-Smith. And that went for about 45 minutes. So I thought I'd show that. It was just a drop of the hat decision to come up. And there was also, Tamitha actually did have a solar report, so I ran that first. It was probably about 8:30 I put that on last week. And then I went into the interview with Lisa and her new book. And then I actually followed that up with another ASV presentation on pulsars. PhD student Rami, can't remember his surname right now, but that was good. Ultimately, it finished right on midnight. So for those that decided to catch up with the YouTube presentation and on the repeater, that's where I was. Anyway, all right, let's get into the first article for tonight. There's a few of them, but I'll try and be quick. Some might require a little bit of editing on the fly, but we'll see how we go. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, broadcasting now since 1988, but not every Friday, but close to it. Okay, it appears that the NASA Parker probe flew right through a massive solar eruption and caught it all on camera. This is courtesy of space.com. Sorry, sciencealert.com. 20th of September. And there's a little picture here of Parker. I'll throw that up. It's there. Okay. NASA's Parker solar probe flew right through a massive solar eruption and caught the whole thing on camera. It's the first up-close footage ever captured of a solar explosion like this, they say. The video, which I'll show in a minute, and like I say, if you're not watching my YouTube or the TV repeater, YouTube's probably the best thing to locate right now. Just type in VK3CSJ in the YouTube search engine and look for the live symbol. But anyway, you can catch up later because this gets recorded and stays on YouTube for the rest of my life, so you can always catch up with it again. The video released by scientists at Johns Hopkins Applied Physics Laboratory features an especially powerful coronal mass ejection that took place last year. Well, this was last year? CMEs are large explosions of superhot plasma that erupt from the sun's atmosphere. They consist of charged particles that can trigger radio blackouts and cause other mayhem if they strike Earth. NASA said that the CME that struck the the Parker solar probe was one of the most powerful coronal mass ejections ever recorded. Luckily for those scientists currently studying the Sun, NASA's Parker solar probe flew right through the CME and survived it, capturing the event on camera, which now I will show that little video. And it should be just this one here, and I'll bring that up, and there it is. In fact, I'll put it on a loop because it only goes for a short while. Oh, there's lots of audio there. Let me see if I can pick that audio. Alright. Yep, okay. So there it is. That goes for 40 seconds, this clip. But you can see right now how massive this CME was as the probe went through it. NASA said that the CME that struck Parker solar probe was one of the most powerful coronal mass ejections ever recorded. Luckily for those scientists currently studying the Sun, NASA's Parker solar probe flew right through the CME and survived it. The eruption starts at around the 14-second mark in the clip below. So, according to Johns Hopkins Applied Physics Laboratory, CMEs can fire magnetic fields, sometimes expelling billions of tons of plasma, anywhere from 60 to 1,900 miles per second. As for the one last September, Parker clocked particles accelerating up to 840 miles per second, according to Johns Hopkins. The data may help physicists understand what propels CMEs and sends particles careening at such high speeds. The Parker solar probe was designed specifically to study the Sun. Not only is it the fastest spacecraft in history, but it's also the one that can come closest to the Sun, within 4 million miles of its surface, and survive the journey. We knew from the beginning that the Parker solar probe would fly through CMEs. Jim Hinkinson, the Parker Solar Mission Systems Engineer at APL, said in a Johns Hopkins statement. So NASA designed the probe to withstand the scorching temperatures near the Sun. The spacecraft is fitted with a custom heat shield, as well as an autonomous system that protects the device from the Sun's light emissions. When Parker first detected the CME, it was about 5.7 million miles from the Sun's surface. Later, the probe travelled in the wake of the CME shockwave. The Parker probe spent almost 2 days studying this one, CME, and came out unscathed. So there it is. All that emission that's going on there, it's really quite stunning stuff. Those charged particles. You're tuned to VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. Alright, my little pussycat here is going around my legs down there. Go back to sleep. You were sleeping on my bed. You should have been quite happy with that. Alright, next article. The sun's death could mean new life in the outer solar system. What are we talking about? September 21, courtesy of astronomy.com. What will happen to the solar system when the sun dies? It might be the end of the planet Earth, but life could still find a way. In roughly 5 billion years, the sun will run out of energy and drastically alter the solar system. Oceans will be baked dry, entire planets will be consumed, and long icy worlds will finally enjoy their day in the sun. Our star is powered by nuclear fusion, and it turns hydrogen into helium in a process that converts mass into energy. Once the fuel supply is gone, the sun will start growing dramatically. Its outer layers will expand until they engulf much of the solar system, as it becomes what astronomers call a red giant. It's just a little artistic graphic of that here. So let me show that. I didn't put it across. There's always one picture I forget to show. It's just an artist's impression. So it's really. I don't know why I didn't move that across. Why isn't it there? Oh, I didn't save it. Okay. Oh, it's more mucking around. Oh, you'll have to take my word for it. Where are we? Is there anything else? Oh, that's the other thing I put. Yeah, okay. I did save one image here. There it is. Bring that up. Okay. Alright. So, and what will happen to the planets once the Sun enters the red giant phase? Question mark. The solar system's is still a subject of debate among scientists. Exactly how far the dying Sun will expand and how conditions will change aren't yet clear, but a few things seem likely. The slow death will kill off life on Earth, but it may also create habitable worlds in what's currently the coldest reaches of the solar system. Any humans left around might find refuge on Pluto and other distant dwarf planets out in the Kuiper Belt, a region past Neptune packed with icy space rocks. As our Sun expands, these worlds will suddenly find themselves with conditions necessary for the evolution of life. These are the delayed gratification habitable worlds, says planetary scientist Alan Stern of the Southwest Research Institute. Late in the life of the Sun, in the red giant phase, the Kuiper Belt will be metaphorically Miami Beach, Stern says. Let's take a quick jaunt through our solar system in the last days of the Sun. And what you're seeing on the screen right now is the life cycle of the Sun. Takes it from the life-giving star we know today into a swelling red giant and eventually a planetary nebula surrounding a tiny white dwarf. Times to look forward to. Mercury. Throughout solar system history, the innermost planet has been baked by the Sun, but even today, Mercury still clings to some icy patches. As our star ages, it will vaporize those remaining volatiles before eventually vaporizing the entire planet in a slow-motion version of a Star Wars Death Star. Venus is sometimes called Earth's twin because the neighbouring worlds are so similar in size and composition, but Venus' hellish surface shares a little in common with Earth's Goldilocks perfect conditions. As the Sun expands, it will burn up Venus's atmosphere. Then it too will be consumed by the Sun. Earth, while the Sun may have 5 billion years left before it runs out of fuel, life on Earth will likely be wiped out long before that happens. That's because the Sun is actually already growing brighter. By some estimates, it could be at least as a billion years before the Sun's radiation becomes too much for life on Earth to handle. That might sound like a long time, but in comparison, life has already existed on this planet for well over 3 billion years. And when the Sun does turn into a red giant, the Earth will also be vaporized. Perhaps just a few million years after Mercury and Venus have been consumed, all the rocks and fossils and remains of the creatures that have lived here will be gobbled up by the Sun's growing orb, wiping out any lingering trace of humanity's existence on Earth. But not all scientists agree with this interpretation. Some suspect the Sun will stop growing just before fully engulfing our planet. Other scientists have suggested schemes for moving Earth deeper into the solar system by slowly increasing its orbit. Thankfully, this debate is still purely academic for all of us alive today. Mars. Even our young Sun's radiation was too much for Mars to hold on to an atmosphere capable of protecting complex life. However, recent evidence has shown that Mars may still have water lurking just beneath its surface. Mars may escape the sun's actual reach, it's at the borderline, but that water will likely be gone by the time the red planet or a giant star takes over the inner solar system. As far as the gas giants are concerned, as our red giant sun engulfs the inner planets, most of the material will likely get thrown deeper into the solar system to be assimilated into the bodies of the gas giants. There's a picture here of Saturn, which I'll throw up. There it is. Oops, that's me. Try again. Okay. However, the approaching boundary of our star will also vaporize Saturn's beloved rings, which are made of ice. The same fate likely awaits today's icy ocean worlds like Jupiter's moon Europa and Saturn's Enceladus, whose thick blankets of ice would be lost to the void. And in this image you're seeing on the screen right now, they say here that the ringed planet shows a side never visible from Earth. Cassini took 96 backlit photos of this mosaic on April 13, 2017. Because the sun shines through the rings, the thinnest parts glow brightest and the thicker rings are darker. That's what that image is. So once the sun has become a red giant, Pluto and its cousins in the Kuiper Belt, plus Neptune's moon Triton, may be the most valuable real estate in the solar system. Today, these worlds hold abundant water ice and complex organic materials. Some of them could even hold oceans beneath their icy surfaces, or at least did in the distant past. But surface temperatures on the dwarf planets like Pluto commonly sit in inhospitable hundreds of degrees below freezing. But by the time Earth is a cinder, the temperatures on Pluto will be similar to our own planet's average temperatures today. When the sun becomes a red giant, the temperatures on Pluto's surface will be about the same as the average temperatures on Earth's surface now, Stern says. In a research published in journal Astrobiology in 2003, he looked at the prospects of life in the outer solar system after the sun enters its red giant phase. Earth will be toast, but Pluto will be balmy and brimming with the same sorts of complex organic compounds that existed when life first evolved on our own planet. Stern says that Pluto will likely have a thick atmosphere and a liquid water surface. Collectively, the worlds from comet-like space rocks to dwarf planets like Eris and Sedena in this new habitable zone will have 3 times as much surface area as all 4 of the inner solar system planets combined. This might seem like an academic discussion only relevant to our distant descendants, if they are lucky enough to survive billions of years from now. However, as Stern points out, there are around 1 billion red giant stars in the Milky Way galaxy today, and that's a lot of places for living beings to evolve and then perish as the stars consume them. So, yes, the future of this world is nigh, as they say. You're tuned to VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Alrighty then. Okay, this is courtesy of Space Exploration, the Astronomical Society of Victoria's Space Exploration page. Thank you, Kate Green, for your amazing work you do with the Facebook page, always putting up articles. This one's called First Contact Could Turn Out Well for Humanity, September 21, 2023. You've heard this story before. An advanced alien race comes to Earth. They offer peace and prosperity, but they hold a dark secret, one that could destroy humanity. That dark secret has varied over the years, from stealing our water, books and culinary advice for communism, but the result is always the same. First contact with advanced extraterrestrials goes very badly for us. But in reality, How bad could it be? That's the question a new study examines using game theory and Hobbesian philosophy. The simple argument against alien contact comes from our own history, when European colonizers made contact with the nations of the Americas. The result were genocide and destruction of the American civilizations. So the argument goes, if an advanced alien fleet comes to Earth, we should expect the worst. However, Europeans come to the Americas with the specific intent of subjugation and exploitation, which might not be true for alien explorers. And while giant spaceships hovering over major cities can make for good cinema, it's much more likely that the first contact with aliens will be by radio, with an exchange of information across the light years. So we should probably take a more game theoretic approach to this first contact concept. One way to approach the problem of first contact is through the Hobbesian trap, also known as the Schilling's dilemma. I think it's how you pronounce that. Suppose you get lost in the woods and meet a stranger. The best outcome is for the two of you to work together to find a way out of the woods. But you don't know this stranger. They might beat you unconsciously and steal your stuff, so maybe you should beat them first. Even though the best outcome is cooperation, the safest outcome is betrayal. The conclusion seems to be that contact between alien civilizations would likely lead to their destruction rather than an alliance. This has been used as one explanation for the Fermi paradox and why we haven't yet discovered aliens. But in this new paper published in Space Policy, the author argues that the Hobbesian logic is the wrong approach. The trap arises because both sides have adopted a risk-adverse approach. That is, it's better to be safe than sorry. An alternative would be to take a reward approach, which the author feels is more likely. The argument is that if we make contact with alien civilization, we will actually know quite a bit about them. We'd know that they evolved in the same physical universe as us, with all the evolutionary challenges. We'd know they have developed technology, which requires a level of cooperation and mutual benefit. And if they can travel through interstellar space to reach us, they have likely overcome major social and environmental challenges. So even though we can't assume their intentions are completely benign, we also know that there would be a tremendous benefit to cooperation and information exchange. So our best strategy is to take a beneficial approach. Then this would also be their best strategy, and they likely know it. From this, the author develops a set of axioms of first contact, outlining some basic rules of engagement when meeting an alien species. Very broadly, they are to understand that communication is possible between us, that we should be cautious but hopeful, and that first contact is not likely to be an existential threat. There are strong mutual benefits to contact. When humans work together and trust each other, our world becomes a better and safer place. Perhaps the same can be said about humans and aliens. There we go. Thanks to Kate Green for putting that article up on our Facebook page, the Space Exploration Astronomical Society of Victoria. This is VK3EKH, ASV Radio. Nobody else has sent any further emails. Where are you all? Why? This is a quickie. Why is Jupiter not a star or a brown dwarf? And there's a little image for this. I missed the one for Pluto, but it doesn't matter. Okay. Although the most massive planet in our solar system, Jupiter does not contain enough material to ignite fusion. Although 318 times more massive than Earth, Jupiter would need 80 times more mass for its core to be hot enough to sustain thermonuclear fusion. The creation of helium from 4 atoms of hydrogen with the release of energy. Fusion generates the energy that allows stars to shine. Brown dwarfs are not massive enough to sustain fusion either. These failed stars, however, form entirely from interstellar gas. Planets, on the other hand, assemble from dust and gas of the remnant disk that forms while the star is accreting matter. The two classes may, in fact, overlap, as for now we do not know. Additionally, today the International Astronomical Union places the dividing line between brown dwarfs and planets at 13 Jupiter masses. And this is the minimum mass required to ignite deuterium fusion. Deuterium is an isotope of hydrogen, of course. That was just a quickie. Dear. And am I still? No, there I am. Okay. Next article. This is something that's about to happen. NASA's OSIRIS-REx asteroid sample is about to return to Earth. OSIRIS-REx. OSIRIS-REx asteroid sample return capsule will land in Utah on September 23rd at around 10 a.m. 1400 hours GMT. Here's the latest. This is 18 hours ago. And there is a bit of a picture here of the capsule landing. It's kind of a, I think this was just a test that they did, and they photographed how it was going to look. So that's what you're seeing there. On September 24, NASA's OSIRIS-REx mission will make history by returning samples of the asteroid Bennu to Earth after 7 years in deep space. Launched in 2016, the OSIRIS-REx spacecraft reached asteroid Bennu in October 2020 and collected samples from the near-Earth asteroid surface. On September 24, it will return those samples in a special capsule parachute, with landing set at 10 a.m. Department of Defense's Utah Test Training Range near Utah. See the latest on the asteroid sample return approach. So that was a quickie too. Oh, there's another picture here. Where is it? There it is. That image you're seeing on the screen right now, the European Space Agency's optical ground station telescope in the Canary Islands captured this photo of NASA's OSIRIS-REx asteroid sampling probe on September 16, when the spacecraft was 2.9 or 4.66 kilometers. I'll say that again. 2.9 million miles or 4.66 million kilometers from Earth. We just got a look at NASA's OSIRIS-REx probe in deep space as it carries its asteroid sample toward Earth. So that little dark patch in that red square that you can see on the screen there, that's the probe. When the image was taken, it was 2.9 million miles away, 4.66 million kilometers away from Earth, having already journeyed nearly 1 billion miles since leaving asteroid Bennu, Bennu. So there's a little update on NASA's OSIRIS-REx, which is about to land. Let's hope it's successful. Looking forward to seeing what comes from that. This next article I might quickly, it's not very long, I'll just see how far, I might just make it enough to whet your appetite type article. We need a better way to map Earth's magnetic field. Finding it could win one of these teams $2 million, published 14 hours ago. The magnetic shifts can affect navigation systems used by airplanes, ships, and even your mobile phone. And the picture on the screen right now is a map of Earth's magnetic field as of September 2014. A technology competition to devise a new means of more accurately measuring Earth's magnetic field is entering its final phase, with one competing team in particular utilizing quantum effects in diamonds to measure shifts in the magnetic field. Scientists map and track Earth's magnetic field using something called the World Magnetic Model, WMM, which was jointly developed by the British Geological Survey and the US National Geophysical Data Center. Because Earth's magnetic poles have a tendency to wander, the WMM must be updated regularly, at least every 5 years. Since the WMM is used by aviation authorities, NATO, defense ministries, and shipping navigation, any inaccuracies could ultimately lead to potentially dangerous scenarios, such as ships and planes going off course. And although we might not realize it, over 1 billion of us make use of the Earth's geomagnetic field in our daily lives, as our smartphones contain a device that uses the WMM to account for the deviation between magnetic north and true geographic north, which is part of how your phone knows which way you are pointing. In an effort to spur advancements in how we measure Earth's geomagnetic field, Luminary Labs in New York is holding a MagQuest competition. MagQuest has just announced which 3 teams will progress from Phase 3, receiving $900,000 prize money in the process and entering the final round and the chance to win $2.1 million. Okay, I'm going to leave that there because it just goes into a bit more detail on the teams. But if you want to follow up on that article, it's space.com. In fact, I think this is a bit across the board. But anyway, this is space.com. And look, I think it's under spacecraft heading. We need a better way to map Earth's magnetic field. Finding it could win one of these teams $2 million. So I just thought I'd wet your whistles on that one. And back to me. We've still got YouTube, that's good. All right. In this article, a close call. 2 huge pieces of space debris had a near miss in orbit 16 hours ago. The distance between 2 objects was around just 118 feet, 36 meters. And there's a bit of an artist's illustration of that. And did I get that across? Did I? Yes, there it is. There it is, for those watching the visions. 2 big pieces of space junk almost slammed into each other in low Earth orbit, highlighting the need to clear up space close to home. LEO Labs, a space traffic management service which tracks satellites and other objects in space, spotted the close call on September 13. As a defunct Soviet payload and a spent Chinese rocket body whizzed by each other at incredible speeds, the conjunction of the 2 objects saw the pair pass each other head-on. LEO Labs identified these as likely being Cosmos 807, an 880-pound or 400-kilogram payload launched in 1976, and a roughly 4,400-pound, 2,000-kilogram Chinese Long March 4C rocket stage launched 5 years ago. Each would have been travelling at around 7.5 kilometres per second as they passed overhead at an altitude of around 689 kilometres above. A collision of these highly energetic mass chunks of space junk would create around 3,000 pieces of debris in low Earth orbit, according to Leo Labs. Earth's atmosphere is very tenuous at this altitude, meaning it would take a long time for even the smallest pieces of debris created by such a collision to fall back to Earth out of harm's way, increasing the danger for satellites operating in similar orbits. Leo Labs calculated that the miss distance was 118 feet, 36 metres, plus or minus 13 metres, giving the probability of collision at 0.1% for 1 in 1,000. However, both pieces have had tens of other close calls with other pieces of junk or orbital operational satellites in the last couple of years. At orbital speeds, even tiny pieces of debris can inflict incredible damage, and this could threaten astronauts aboard the International Space Station or Chinese Tiangong Space Station, or the ability to utilize orbits in Earth's observation, science, communications, and more. A recent report from the European Space Agency noted that while new measures to mitigate space debris are being adopted by countries and companies, the existing debris in orbit makes our behaviour in space unsustainable. The new close call highlights the need to clean up our acts in space and reduce the chances of cascading growth of dangerous space debris known as the Kessler Syndrome, Kessler, Kessler Syndrome. Oh dear, there's things are going to happen out there one way or another. It's not good. Alright, 8 minutes to the hour. Right, here's a bit of a plug, as I usually do, for this website. Just bringing it up. There she blows. Astrophiz.com. Take a listen. There's now 179 podcasts that Brendan O'Brien has created, and the most recent one is Dr. Daniel Plumbo. The Event Horizon Telescope is what he's talking about. He says, we speak with Dr. Daniel Plumbo from the Harvard-Smithsonian Center of Astrophysics. Daniel is an astrophysicist and data scientist with the Event Horizon Telescope who worked on the amazing black hole images using data from the planet-sized telescope, the EHT, the Event Horizon Telescope. He is involved in ongoing work on the Next Generation Telescope Consortium, and in this episode he shares his science journey, how the EHT works, and how it worked with imaging teams to produce those two historic, stunning black hole images from our Milky Way galactic center, Sagittarius A, and the more distant supermassive black hole in Messier 87. Brilliant science, beautifully explained, says Brendan. So there it is. Go and listen to Astrophiz 179, astrophiz.com, and be thoroughly educated with that one. Thanks, Brendan. You do bring some amazing podcasts to our ears. Right, next. Oh yeah, this is a quickie. I like quickies. And there's an interesting image associated with this one. So, what is this you're looking at on the screen right now? You may ask yourselves, for those that are watching. Oh, nothing like finishing off a cold cup of coffee. Where is the center of the universe? Have you often asked that question? Although it is hard to imagine, there is no center, no edge to our cosmos. Where is the center of the universe? Where the Big Bang occurred? Where is its edge? As counterintuitive as it may seem, the universe has no center and it has no boundaries. The idea of a Big Bang acting like a giant fireworks explosion hurtling matter and energy outward is pervasive but misleading. As bizarre as it sounds, it wasn't stuff that exploded outward, it was space itself. In essence, the Big Bang happened everywhere. Since the time of Einstein, it has been known that space is not simply a backdrop in which we move, but an actual thing that can be measured. It has shape, it can be bent, and it can expand. If this sounds nonsensical, think of the surface of a balloon expanding into three-dimensional space. A two-dimensional creature confined to the surface of the balloon could never find the center because the center is located in 3D space and not in the 2D space in which the creature lives. We are 3D creatures stuck in a universe with at least 4 dimensions, so we cannot see the center of our universe. In fact, there is no reason why there has to even be a center anywhere. The same reasoning holds true for the edges of the universe. Where is the edge of a balloon? To define an edge or a center, you need to assume that there is something into which the universe expands. As I just explained above, that need not be true, and even if it is, we can never detect this metaverse. When thinking about cosmology, always remember the words of a British biologist, J.B.S. Haldane. The universe is not only queer than we suppose, it is queerer than we can suppose. Right. Well, the universe is not only queerer than we suppose, it is queerer than we can suppose. I reckon they could rewrite that these days. Anyway, so there it is. I thought that was an interesting little quickie to throw into the scheme of things. Where is my picture? There it is. Good evening. All right, I think we're about to finish. I think we're about to head up to spaceweather.com, are we? Yes, we are. The sun. Let's have a look at the disk. The current disk of the sun looks like this. I know I put it there, but it's not. All right, let me just bring it up. It's always something. Image. There it is. Browse. There it is. Open. Okay. Good old vMix. Wonderful vMix. There she blows. All right. So what we're seeing there is the current disk of the sun. And there's multiple sunspots across the disk. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. About that. Very quick count. 11 sunspots. The solar wind is currently at 399.8 kilometers a second at a density of 4.09 protons per cubic centimeter. The current sunspot number is 159. The radio sun, measured at a wavelength of 10.7 centimeters, the current flux density is 156 solar flux units. The cosmic ray count is continuing to go down, and I can show you that graph. There it is. So since the beginning of solar cycle 25, the solar radiation count continues to drop as a result of solar radiation increase. The current auroral oval is looking like this, which I didn't bring across. Let me just quickly do that. Image, there she is, bringing up right now. Stand by. Okay, there it is. So there's the current auroral glow over the Antarctica. It is predominantly beaming towards Tasmania and New Zealand as we speak, but there's nothing very intense in it. There might be a very subtle glow if you look south from Hobart in the skies, but nothing to write home about at this point in time. They say, the K index, let me talk about that. The planetary K index. Currently the K index, KP figure, is 2.67, which is considered quiet. The 24-hour max KP figure is also 2.67 and is considered quiet. This weekend, geomagnetic storm watch. High altitude photographers, prepare your cameras. There's two CMEs from sunspot AR 3435 are expected to graze the Earth's magnetic field this weekend, September 23-24, sparking a G1 class geomagnetic storm. Auroras could spill from Arctic Circle down to the northern entire US states and that area. Conversely, the same for us down here. And there was an interesting night storm photographed from an aircraft, and I'll just bring that up because I did put that across. Did I? Oh, no, I didn't. Let me show you this image. I'll just bring it up in a second. There it is. Don't know why I didn't bring that across. There we go. There is. So what you're seeing there is the night after the storm, they're calling it, when a CME hit Earth on September 18th, sparking a strong geomagnetic storm. It was just the beginning. Our planet's magnetosphere reverberated for more than 2 days after the impact. And of course the image there is some amazing auroral images taken from an aircraft. This is on a flight back to Europe. The night after the big storm, the author was saying he flying back to Europe over Greenland, while over Greenland's ice sheet, with amazing auroras appearing, with even blue northern lights were there. So yes, there it is. Very nice picture, isn't it? One day I'll see all this. It'll be really good. Okay, and one more graph, just to show you the current solar cycle where we are. So for those watching TV and YouTube, that is where we are on the current cycle of things. We're still, a few years from peaking, a year or two from peaking for solar cycle 25. So there's lots of interesting HF activity to come, and lots of interesting solar flares to record on your chart recorders for those doing that sort of thing. And I think that wraps it up. As far as near-Earth asteroids are concerned, potentially hazardous asteroids, there are, as of September 22, just a sec, bring my camera back up. Alright. As of September 22nd, 2023, there are 2349 potentially hazardous asteroids. That's 2,349 potentially hazardous asteroids, and there's a big list of them on spaceweather.com just there. Okay, I think that's about... Oh, there was just one more thing. Look, it's 4 minutes past the hour, and I'm still going to throw this one thing in here. Oh yeah, okay. Excuse me. This fella. No, I did. Oh, yeah, there he is. Okay. All right. We all know, for those watching Visions, we all know what that is. NASA's Ingenuity helicopter on Mars just broke an altitude record on its 59th Mars flight. So, isn't this amazing that this little helicopter on the surface of Mars is still flying. 59th Mars flight it's been doing. On September 16, 2023, it soared to new heights, reaching an impressive altitude of 20 meters, 66 feet, during its 59th flight, setting a new record for off-Earth flight. This achievement is a testament to the ingenuity and engineering prowess of the NASA team. Ingenuity, weighing just 4 pounds, 1.8 kilograms, has been a pivotal part of NASA's Perseverance rover mission since its historic landing February 2021 within the Jezero crater on Mars. The crater, once home to a lake and a river delta, is a prime location for scientific exploration. Perseverance is diligently searching for signs of ancient Martian life and collecting samples that will eventually be returned to Earth. So I thought that was good, that little guy is still doing great guns. So isn't it amazing what we can do on another planet? I can't wait to land there. Put that foot. If it's the last thing that I see on my dying bed, my last breath is to see a man set foot on that surface of that planet. I saw it happen in 1969 with Apollo 11 and Mr. Armstrong, and I want to see it again with Mars. Okay, let me get my logbook. So, this is VK3 Echo Kilo Hotel. We shall now take a quick listen on 3541 kilohertz for any stations wishing to check in. I don't have the audio connected to the system here, so the audio feed from my receiver will not be going out over the ATV repeater or YouTube. So I'll just turn the volume up a little bit and you might be able to hear yourselves. But anyway, just a sec, let me make sure my pen works. Yes, this is EK3 EKH listening on 3541 kilohertz.
EK3 BDA Bendigo from EK3 TGS. EK3 Delta X-ray Europe.
Okay, there was a double there. I've got VK3 BDA, VK3 TJS, VK3 Delta X-ray, but there was a double. Who was the other station? Okay, got you there, Andrew. And who was the other station? I think it was a VK2.